Welcome to today's session. Today's session, we will learn to build regression model using H20.ai. H20.ai is an open source machine learning platform. It is built using Java programming language. It is a distributed parallel processing engine. The key features of H2O is it has a web-based interface called Flow, wherein data scientists can import, explore, and modify their data set. They can try out different complex models, verify their performance, and deployment is very simple. It also has an AutoML feature which provides automatic tuning and hyperparameter tuning of complex model with very less or negligible input from user, and it is distributed and in-memory processing. So today, let us see using AutoML feature, how will we build a regression model. To recap on regression, what is regression? Regression is a supervised machine learning technique wherein using the historical label data, models try to predict numerical value. H2O AutoML, why it's so fascinating is it tries to ensemble a complex machine learning model starting from deep learning, extreme random forest, and extreme gradient boosting model, generalized linear models. All the complex models are built in background with very less input or negligible input from user. It completely automates the machine learning workflow process, starting from training and parameter tuning. So let's see how this works. Before starting this tutorial, I request you to install the required packages mentioned in the installation notes. So first, we have to import the H2O library, import OS, import H2O, and import H2O.automl. So let me execute it. So once that is done, the next line, I'm just setting the working directory. H2O.init function instantiate H2O.ai instance in your local machine. So once I execute this line, it will create a localhost instance of H2O server within the local machine. So it will also print which version of Python is being used, where the error log and print system out will be printed. Today we will be doing this example using this data set from Kaggle. It is a data of 50 startups from 17 states in US. It has following columns: R&D spend, research and development spend, administration spend, marketing spend, state, and profit of the company. So it has around 50 rows, and we'll use this data to do a regression model because we are predicting profit, which is a numerical value. First, we have to import the data. So for that, we will use h2o.import file and give the file name. So let me execute it. So once that is imported, you'll get 100% here, and you can use train.head function to see the first few records. So once that is done, then we can use .describe function to see the or understand the data type and summary. So it shows it has 48 rows, 5 columns, and data type of R&D is real, administration is real, marketing spend is real, state alone is enumerator, that is character with multiple values, and profit is also real. Second row states the minimum value for each column, and the mean, maximum. Zeros, it will say how many columns has values, row values has 0. Is there any missing value? And it also will list on the first few records. So after understanding the data structure, we have to specify for the model, like what is the target variable in Y, and X would have the list of independent variable. So here target variable is profit, and independent variable we'll be using is R&D spend, administration, marketing spend, and state. So once these two values are set, we will call the AutoML function. So AutoML requires a very minimal user input. So input, what we have to give is number of models which we want to try. So here I've given maximum models to be tested as 10. Max runtime is 120. So it should not exceed 120 seconds. And seed equal to 1. Seed is mainly used because the machine learning model works on randomization. So in order to replicate the same result every time in every iteration, if we use the same ID, you'll get the same result. So that is the purpose of seed. Then the second line we have to specify AML.train and give the X value and the Y value and the training data frame. That is done. It will show the progress bar. Default randomized forest, extreme randomized forest, random grid of gradient boosting machines, random grid of deep learning, deep neural net, and fixed grid of generalized linear models. It tries to build an ensemble model using these models and tries to form a leadership board. So let me show what the leadership board is. So I can extract the leadership board using AML.leadership board and then print the models. The next few columns are the error metrics. Error metrics is used for evaluating the model performance. So how good the model is. So since these are all errors, so lower the value, better the model. So let's see what each error means. Mean residual deviance is nothing but mean of sum of errors square, error square. It is same as MSE, mean square error. Mean square error is nothing but I'll give you an example. So if actual value of Y is 10 and predicted is 30, the square of error is 30 minus 10, the whole square, that is 400. So for each row data, this value square, sum of square is found, and then mean is calculated. So that value is MSE. MAE is mean absolute error. So here the mean of absolute difference for all data is computed. Then root mean square error. Root mean square error is square root of MSE. So using these evaluation metrics, we can evaluate which model is best. So in this example, the GBMS gradient boosting model of this combination has performed best. For testing or evaluating or validating the results using the test data set. What is test data? Test data is a set of records which is kept aside so that we can evaluate the created model using the unseed data and check if we are getting similar kinds of result as we got for the training set. So first we have to import the test data. That is done using the .import file function. So once data is imported, then we have to use AML.predict and pass on the test data to predict the values. So using the best model, it will try to do the prediction, and here are the predicted values. Let's print the test data set to see the actual profit values. The actual profit is comparable to the predicted values. We have read through in the machine learning terminology readout. R square is used for measuring the accuracy of regression model. We have a package to compute R square score, and to which we have to pass the test data and the predicted values. The output is around 88% accuracy, which is good enough. Hope this session was useful. Meet you in the next session. Thank you.